All right, geometry students, we are moving into our next type of transformation. I'm going to talk about reflections today. So we should be able to recognize and apply patterns to reflect or flip figures across a line of reflection in the coordinate plane. So first we're going to define reflections. We're going to practice reflecting across the x and y axis and what patterns exist there. We're going to reflect across horizontal and vertical lines and reflect across the lines y equals x and y equals negative x. Make sure that you're following along with your guided notes and let's get started. So a reflection is a flip over a line called the line of reflection. Pretty straightforward so far. Reflection. Each point in its image are the same distance from the line of reflection. So for example, B and B prime are the same distance away from the line of reflection. In this case, it would be the y-axis. A reflection is also an example of a rigid motion. And if you remember the definition of a rigid motion, it's just a transformation that results in a congruent figure. So when you reflect across a line of reflection, your resulting figure is congruent to the preimage. Some of the common lines of reflection would be the x-axis or the y-axis, vertical or horizontal lines in the form of x equals a number or y equals a number. For example, x equals -3 or y equals 2. X equals -3 or any line starting with x equals would be vertical. And any line starting with y equals and ending in a number would be a horizontal line. And we also are going to talk about diagonal lines. For example, y equals x where the slope is 1, or y equals -x where the slope is -1. So when we reflect in the x-axis and the y-axis, there are some patterns that we need to pay attention to. So for question 1, when we have triangle ABC with vertices A, B, and C, and we reflect across the x-axis, let me highlight this line of reflection here. The x-axis right here. We're going to make sure that the pre-image and the image are the same distance from the x-axis. So for A, the vertex is -4, 2, -4, +2. Here's A. B is at 4, 7. And C is at 5, 1. So here is our lovely triangle. And we want to reflect this triangle so that each image point is directly across from it. We're going to create a mirror image. Here's the rule that's really important to note for reflecting across the x-axis and the y-axis. When we reflect across the x-axis, our x coordinates are going to stay the same. Here's the rule for reflecting across the x-axis in coordinate notation. So starting with the pre-image point xy, it's going to become x negative y. When you think of this, think same x, opposite y. So here is our image. A is at point -4, +2. So A prime is going to be at -4, -2. -4, -2. Here's A prime. Same distance across the line. It is 2 coordinates away from the line, so is A. B prime, well, B is at 4, 7, so that means B prime is going to be at 4, negative 7. So B is at 4, negative 7. Here's B prime. C prime is going to be 5, negative 1, changing the sign of the y value. 5, negative 1. Okay, and here is my image. We completely flipped this triangle across the x-axis. Now let's try reflecting across the y-axis. So problem 2 states that rectangle PQRS is being reflected across the y-axis. And let me highlight in yellow the y-axis here. This is my line of reflection. That means each pre-image point and image point should be the same distance across that line. Okay. So starting with, PQRS, P is at 1, 2. Q is at 2, 5. P, Q. And then R is at 8, 3. S is at 7, 0. Lovely rectangle here. And so here's the rule that we use to reflect across the y-axis. When we reflect across the y-axis, our y values are going to stay the same. So the rule xy maps onto negative x, y. Same y, opposite x. So here's what our image rectangle is going to look like. So our original point P is 1, 2. So P prime should be negative 1, 2. Again, x changes sign, y stays the same. So P would be at negative 1, positive 2. And notice how these points are exactly the same distance from the line of reflection. P is 1 coordinate away, P prime is 1 coordinate away. Q was originally at 2, 5, so Q prime is at negative 2, 5. Negative 2, and then up 5. Here's Q prime. R prime will be at negative 8, 3. Negative 8, positive 3. And S prime is going to be at negative 7, 0. Negative 7, 0. And here is our reflected rectangle. For additional practice with reflecting across the x-axis and y-axis, try out problems 3 and 4. Let's practice when we have to reflect across lines that are not, the traditional x and y axis. So for number 5, we're reflecting triangle JKL across the line x equals 4. And my advice to you would be to graph these lines before you complete the reflection. Makes things so much easier. So x equals 4 is a vertical line at the point x equals 4. Every x value will be positive 4 on this line. So I'm going to graph my vertical line. Let me highlight here. Doesn't have to be completely perfect here, but this is representing the line x equals 4. And so let me graph my triangle, my pre-image. JKL, J is at 1, negative 1. K is at 2, positive 3. And L is at 3, negative 2. Here is JKL. Okay, and so let's find the image points. This time there's not really a rule to this, but you just want to make sure that your image points are equal distance from the line of reflection as the pre-image points. So if I look at L, I notice it's one coordinate away from the line of reflection. I'm going to go one coordinate the opposite direction to plot L prime. J is 1, 2, 3 away from the line. I'm going to stay at the same y value, but I'm going to move 3 units away from the line on the opposite side. Here's J prime. And K prime is 2 units away. I'm going to move 2 units opposite direction. This is K prime. And here is my triangle. And just to confirm the coordinates, J prime is at 7, -1. K prime is at 6, 3. And L prime is at 5, -2. I'd like you to practice 7, 6, 7, and 8 to reflect across other vertical and horizontal lines. Here's another concept where we use a pattern. So we can use patterns to reflect across the lines y equals x and the line y equals -x. When we think about the lines y equals x and y equals -x, know that they have a slope of 1 and -1 and a y-intercept of 0. So when you graph these lines, let me highlight here. For number 9, I'm reflecting across the line y equals x. So I know that it passes through the origin and has a slope of 1. So it's just going to be a completely diagonal line here. And with y equals -x, that also passes through the origin. The y-intercept is 0, and the slope is -1. So we move down 1, right 1, down 1, right 1 for all points. There we go. Okay, so for number 9, when we reflect across the line y equals x, let's plot our pre-image points first. So x is at -5, -2. Here's x. Y is at -3, +4. And z is at -1, +1. So here's x, y, and z. So there's something pretty cool that happens when you reflect across these diagonal lines here. So for y equals x, here's the rule that we follow. And it kind of follows the equation of the line, right? So instead of xy, we're going to switch the coordinates. It becomes yx. All we have to do is switch x and y. And for y equals -x, -x, here's the rule for that one. We take the coordinate xy and we map it onto -y, -x. So we switch the coordinate values and change their sign. So let's continue with problem 9, where we're reflecting across the line y equals x. I know that x is starting at -5, -2, so I'm just going to switch the x and y coordinates. It's going to become -2, -5. -2, -5. And if you checked with the midpoint formula, you could determine that the point that is equal distance from x and x prime is on the line y equals x. Pretty cool. For y is at -3, 4. So I'm going to switch the x and y coordinates. It would be 4, -3. Y prime is at 4, -3. And z is at -1, +1. So I switch those values to get 1, -1. Here's z prime. And you'll notice these triangles are congruent and reflected across that line. Let's try out number 11, where we're reflecting across the line y equals -x. So A is at -1, +3. B is at 0, 6. C is at 3, 5. And D is at 2, 2. So we've got a square here. A, B, C, D. Fix that there. All right. And so now let's use the rule for reflecting across the line y equals -x. So A prime, if we look at the original point, -1, -3, well, it's going to switch, and then we're going to change the sign of the coordinates. So it would be -3, +1. For B, we start at 0, 6. So when we flip the x and y coordinates and change their sign, it's going to be -6, 0. You can't have positive or -0. For C, we start at 3, 5. We'll change to -5, -3. And for D, we're switching, changing sign, -2, -2 is D prime. So let's plot these points. We have -3, +1. We have -6, 0. We have -5, -3. And we have -2, -2. So two congruent squares reflected across the line y equals -x. For additional practice with these lines, you can practice with 10 and 12. And lastly, we're going to practice identifying lines of reflection. And with this particular skill, sometimes it's helpful to find the midpoint of the corresponding points, like between z and z prime. And sometimes you can eyeball it. You can determine which level on the x or y axis is equal distance from your corresponding points. So when I look at these quadrilaterals, w, x, y, z, and w prime, x, y, x prime, y prime, z prime, I'm looking and there is a distance of 1, 2, 3, 4, 5, 6 between z and z prime. So if I move 1, 2, 3 inward, I'm going to find this line here is halfway in between. And if I double check my other points, I notice that y and y prime are 1, 2, 3 points away from that line. W and w prime are 1, 2, 3, 4, 5 points away on either side. And x is 1, 2, 3, 4, 5, 6 points away on either side. This particular line isn't on the x-axis. It's a horizontal line at y equals 1. So the line of reflection is y equals 1. With my next line, this one's going to be a little bit trickier, but I know it's going to be a diagonal line. I can't really reflect these quadrilaterals across a horizontal or vertical line and get them to look the way they do. I'm starting to see that it's a diagonal line. If I test out y equals x, just to check, I notice that I can see that I have to move up 2 and left 1 to get to C prime, and I have to move down 1 and right 2 to get to C. I'm seeing that they are equal distance from each other. And the same with all of the other points. They are equal distance from this line of reflection, and that line of reflection would be y equals x. For additional practice, you can try out problems 13 through 16. And that is our lesson. So make sure that you're trying out additional practice problems, check your answers with my filled in notes, and ask for support if you need it. Thank you so much for watching.